Hi, everyone. My name's Christina Park. I am new to Skydio, but actually not new to the utility industry. I spent 15 years at the New York Power Authority. I started as a hydro engineer, working in power generation. And then in the last 3 years, I actually switched over to strategic operations and asset management. So as of March, I was the senior director of a division called Asset Intelligence Solutions, where we actually had multiple parts of the department that looked at the way that we do operations and maintenance out in the field, and also looking at technology and technical solutions and analytics that existed out in commercially available solutions, and trying to figure out what was viable, what could be operationalized, and how we would scale and implement the solutions. Here at Skydio, I'm the Senior Director of Energy Marketing. So here I work on the strategy to connect the problems that are out in the field with the solutions that we have in house. And I'm really excited today to kick off this series and talk about aging infrastructure and the problems that we face out in the utility industry. So aging infrastructure is kind of like an aging body. I don't know about you guys. I'm pretty much middle aged, but as time goes on, it becomes more and more important to be intentional about having an accurate understanding of your health and doing the appropriate checks and maintenance to ensure that each part of you or parts of your assets are functioning well and not at risk of failing. Right. So if I could give a little bit of a story, once upon a time before I had children, I was a competitive taekwondo athlete. And in my 20s, I could pretty much train however I wanted, get bumped and bruised and broken even, and I would bounce back pretty quickly, right? Even in the face of overuse, right? So that was something that I could do in my 20s. I noticed in my 30s actually that injuries went from being acute to chronic, and healing happened much more slowly than I would have liked. And now that I'm in my 40s, I think those days are long behind me, and just getting up in the morning hurts, right? So when I look at how often I went to the doctor, when I look at how often I stretched and warmed up and cooled down, that actually changes with age, right? And so I think that our infrastructure and our assets are really the same way. They need checkups, they need inspections in the same way. And as your infrastructure ages, you need to increase the frequency or be more intentional about the way that you inspect them. It's actually not just the failures, but the indicators that lead to failures that are important to diagnose and to assess, right? So, at the end of the day, what ends up being in the news is when you have something that leaks, something that cracks, something that breaks, right? Or you have something that explodes. You have a stator that's on fire. You have a transformer that exploded in a substation. So these are the endpoints that you don't want to get to, but ahead of those, there are actually indicators that you can look for and monitor uh, that would let you know that failure is imminent, or that failure is something that you should keep your eye out for. Right. So some examples of those are cracks. If you have concrete, if you have steel, right. Looking at rust. And the effects of corrosion, and also looking at thermal hotspots, right? Wherever you have electrical connections, and really being able to understand uh, how to measure and how to quantify quantities such as temperature or measurements, or gradients that you can see. So reliability is something that's really important to think of, and it's actually a little bit difficult to measure. But reliability depends really heavily on the quality of maintenance and the mitigating actions that are taken to lengthen the life of each asset, right? So no matter what your asset is, you really want it to last as long as possible. So if we go back to the analogy of health in the body, much like ignoring mild chest pains could lead to a heart attack, unawareness of hotspots can lead to breakdowns, or not knowing that there are cracks can lead to leaks. So this is why it's really important to look at those anomalies early on, before you lead to a failure. So I think traditional inspections are really done by your people, right? Like whether you have linemen, whether you have operators, whether you're looking at a gauge, or whether you're actually looking at the amount of rust that's on a component, right? The reality is that a lot of your assets are in places that are hard to get to. And it's actually quite dangerous in some instances to be able to get your eyes where you need to see the components. So I think there are two things you can see here that often it requires rappelling down the side of something. Like if you're doing a dam inspection or a smokestack inspection or a penstock inspection, it requires harnessing somebody up in a way and rappelling them down, which has inherent safety factors involved. The other is if you have an environment like a substation that's energized. I think anyone who works in a utility has a separate set of clothing for your FR, your fire resistant clothing, right? And I think that the first time as an engineer that I took my training in arc flash, I was a little bit scared to step foot in a substation because all you see are things exploding and people catching on fire. And so I think when we think about the reality of those environments that we have to walk into as utility professionals, there is a certain amount of risk and danger that's involved. Some of the other factors that have to be considered are that it's really intensive on your resources. So depending on the location of what you need to inspect, it could be very arduous to get to. I think substations are another example where many of them are remote. Some of them could be a 2 hour drive away, a 7 hour drive away for your personnel. And depending on how many people need to go, that's going to be a carbon footprint on your truck rolls, as well as the labor hours that are necessary to not only do the inspection but to get to the inspection. Traditional methods can be inefficient and insufficient. So again, if we go back to the idea that some of the components that need to be inspected are in hard to reach areas, it's going to be difficult to get somebody on there and to get every inch of it inspected uh, as accurately as possible, as frequently as you would like. So I think there are quite a bit of trade-offs that have to be taken into consideration, given how many assets are critical to the operation of your facility and how often you think you need to inspect them. In order to mitigate the risk, you really have to have a way of assessing what the risk is, right? And understanding and or having an accurate understanding of the state of your infrastructure itself at any given time, right? So then when you find an anomaly, then you can ask yourself the question of, do I repair it, do I replace it, or do I run it to failure? And there isn't necessarily one right answer to these questions. It really depends on how you operate it and your circumstances. But depending on your company's risk tolerance and your risk mitigation strategy, those answers are going to vary, right? So um, when I think about it, I think almost like how it's recommended that you go to the dentist twice a year for a checkup, right? So that is your way of mitigating the risk to your teeth because you assume that within 6 months, if there is a cavity that starts forming, and if you have gum recession that starts forming, that is something that can be detected in early stages if you go once every 6 months, right? And you have some sort of diagnostic. So, in the same way, I think when you look at your assets, such as transformers or circuit breakers or battery banks, depending on what they are, there is some sort of recommendation, typically by the OEM, when you first install an asset, in terms of how often you should be checking it. But as your infrastructure ages, uh, that may not apply, right? Depending on how you run your equipment, depending on your weather conditions and where it's sitting, and a whole host of other factors, there's going to need to be some change to how often you decide to inspect, or how often whether you decide to repair, replace, or run to failure. Ultimately, the goal of any utility, whether you're in the generation, transmission, or distribution space, it's really to keep the lights on for the customer, right? So when a piece of equipment goes down, there's not only the cost of the loss or replacement of that one piece of equipment, but it cascades right into the cost of the outage, the cost of the downtime, and depending on supply chain issues, the wait for when a replacement might become available. So at the end of the day, I think it is critical actually to have maintenance strategies and to actually revisit your maintenance strategies periodically to make sure that you are optimizing them for your infrastructure because you really just can't afford, depending on what your asset is, they are all connected and you really just can't afford to go down. So here, this is one example where you can see a substation, and as the video clip goes on, you will see what happens when a transformer failure occurs. This is obviously catastrophic, not only for the safety of the personnel and for the component itself, which is most likely a total loss here, but the components around it that will be affected by a failure, as well as the aforementioned other downstream effects, such as supply chain, in order to not only mitigate the cost of replacing it, but the time that it would take to get a new one to show up on site. So I think one thing utilities are all trying to do now is try to make more data-driven decisions. So I think especially as infrastructure ages and we really try to understand the state of our asset health, a lot of utilities have moved into using IoT sensors and trying to get more data or data streams and analyze that data in order to get an accurate understanding of when they see anomalies and raise cases for detecting those small problems before they become big problems. So, examples of IoT sensors are vibration sensors, temperature sensors for maybe bearing oil or quantities such as that, or doing gas analysis on your transformers. So, I think this is something that many utilities are doing. Some are sharing data with each other to really understand best practices. So, I think that moving along this journey of censoring is really interesting. And I think that the next step in this is thinking about the assets that you can't censor, right? So, a lot of the equipment that utilities are choosing to censor are their high criticality, high value assets, such as transformers, such as circuit breakers or battery banks. So, it's not realistic and it's really not scalable to censor every single asset that you need to do an inspection on. So if we think about transmission, it just doesn't make sense to put a sensor on every single insulator of every single pole. It's something that would be very arduous, it would be very costly, and it would actually add to your maintenance routine because you would have to maintain the sensors. So this is where a solution with robotics and AI analytics really comes into play because you have at your disposal the ability to have an aerial mobile sensor. So here you can actually cut out a lot of the safety risk of, as we said before, going into places that are hard to reach. But you also have the ability to have a sensor that you can capture multiple areas. Like if we go back to the transmission example, you could go down a transmission line, you could see all of the insulators, you could see where there are woodpecker holes, you could see where you have overgrown vegetation. So you could actually sensor for things that are not practical or possible to sensor for. So I think that technology is advancing rapidly. And I think one of the things that I was looking at in my old role, if I put my utility hat back on in a technology implementation or technical enablement function, is we were looking at robotics as one avenue, sensors as another, and analytics as a third. And I think one thing that Skydio does that's very exciting is that you actually can lump all of those solutions in on one product, right? So we have the payload, we have the robot that can go out and capture the data. The sensor is either a visual camera sensor or a thermal sensor, can get you the data that you need. And our drones have built in software that is smart enough to know what it's looking at and to avoid obstacles when they see them and to really make it as easy as possible to use for anyone to learn how to use, but also to have the data in the cloud and accessible to the decision makers when they need it. So here you can see some actual live footage of the drones doing the inspections in the utility environments. So you can use these drones in substations, in transmission, in distribution, and even to inspect some of your generation assets. So regardless of what you're looking at, you can have confidence that these drones can get to hard to reach areas that it would be much more arduous or unsafe to send a person, and that the drone can do this with efficiency and with clarity. And on top of that, you would actually end up with a full digital record of your inspection, which you would not normally have with a manual traditional inspection. So you can recreate your traditional inspections. For example, if you needed to go and get gauge readings, you could recreate that path and have the drones go. Our drones actually can go and stop at a structure and get a closer look if they need to look at something like a gauge. Or you can do a more holistic inspection of insulators or circuit breakers or switches, and you can go up and around and get a whole 360-degree comprehensive view where you normally would not be able to do that from the ground. So before we dive into the questions, please be on the lookout for an invitation for episode 2 of the Smart Grid series. There will be a link in the chat, and you'll also be receiving an email. So thanks for joining us today. Really appreciate you taking your time. I think there's a reason that the 3 largest utilities and 70 plus others are using Skydio drones, and I would love to share more about this with you. If there are any questions, please continue to drop them in the chat, and we will address them now. Hi, everyone. So hope you enjoyed some of the visuals that we had there. So I'm looking at some of the questions. So if you have any other questions, please enter them in the chat and we'll see what we can get to today. So one of the questions that came up was, it sounds like you're advocating for time-based maintenance. Is it enough just to increase the frequency of inspections? So I think some of the analogies that I gave before regarding medical checkups and things like that do point towards time-based maintenance. That was really just to say that as time goes on and as your infrastructure ages, it is probably prudent to increase the frequency of your inspections because it is likely that deterioration and the effects of deterioration will warrant those. That being said, I think the main advantage of using a technology solution such as drones is really not about increasing the frequency for the sake of increasing the frequency, but about getting a more accurate understanding of the condition of your asset health. So by getting more data points, you could actually verify that your asset is perfectly fine, but it would give you the confidence in knowing that it's fine and being able to focus your resources and your attention elsewhere. Another question is, let me see, how are other utilities maximizing resources through using drones? So I think utilities are at various stages of their journey. I think I came from one that's more like a large municipality, but I think between investor-owned utilities down to cooperatives, everybody, I think, faces the same challenges and faces the same needs. It's a question of the willingness to adopt a change and the ability to really operationalize a piece of technology, such as a drone or a robotic solution. So I think that we have some utilities that are further along in the journey that have really traveled down and prioritized analytics and robotics and trying to find tools that will increase the efficiencies for their workers, and some that are just starting out on their journey, and that's okay too, because I think a lot of times there's a lot to learn from watching somebody go before you and to see what works and what doesn't work. So let's see. Do you have any? So we have a question here. Do you have any examples of damages discovered by the drone inspection within a substation? So I think we have, I can't give the exact name, but we do have an example of a thermal hotspot that was detected with our thermal cameras in a substation. And this is actually a really interesting example. And I think one that, as a former utility professional myself, as I was looking at different vendors and particularly different drone vendors, this is one area that Skydio stood apart because you could actually fly in the substation. So our drones are not subject to electromagnetic interference, and therefore the drones can actually fly not just above, but around and below the conductors and inside and in between the components. So we did find a switch that had a thermal hotspot, and it was very, very small. So it's something, and it was on the top. So it's something that would not have been detected by the naked eye or during a normal inspection where somebody was walking around down below. So that was a really big win for our customer to be able to see that small detail, but then be able to take action on it right away before it cascaded into
into a larger problem. So I think the main benefit that we would have is to really be able to detect those small indicators and those small problems and be able to mitigate them with very little resources, or actually even to choose not to mitigate them if that is not the priority at the time. Let me see. There's another question that says, how do you detect the size of cracks or corrosion on a drone platform, and what is your current capability? So I think this actually would probably be a better question for one of my solution engineers to answer. I don't know, Aaron, I don't know if you're logged in and you could drop some information in the chat on that. Otherwise, I will look that up and get back to you. But I think some of the tech specs would probably be better answered by one of our solutions engineers. Let me see. Another question that came in. Can you talk about the capacity of drones and other ROVs to be used in confined spaces, for example, penstocks? Yeah, so at NIPA, we had hydro was a very big part of our generation, and penstock inspections were a very big topic that came up. So I think with the cost and the danger of rappelling somebody down and building a platform and everything that's involved in doing a penstock inspection, there's definitely been an interest amongst multiple utilities for using a drone. I think obviously you would need to have the capability to operate in a confined and also dimly lit or dark space. And so you would want to find a vehicle that could accommodate that. And I think there was also, I think when I was in my previous role, we thought a lot about whether it would be better to use a drone or to use a crawler or a different type of robot. And I think they all had kind of similar limitations in terms of the visibility being an issue, and whether somebody would have to, how far they could go down and come back up. So this is a piece of technology that is in the works, and I think that it is a use case that will be able to test out pretty soon. But I think that at the moment, those are some of the limitations that exist. Let me go down. Next question, does Skydio offer an environment to store the 3D models or software where we can build a virtual environment of our territories? So yes, we do have a 3D scan feature. And part of the Skydio solution is really in the software, not just the hardware. So I think for myself, I think in my previous role, when I was looking at different vendors, one thing that stood out to me about Skydio was I thought it was another drone vendor with a robotics platform. But it's actually more of a software vendor that happens to run on a robot. So I think that we have a feature called 3D Scan, which you can find more information on our website, or we could certainly follow up and send it to you. But you have the ability to actually go and render a 2D or a 3D model by flying around a transmission tower or flying through an internal power plant or whatever it is that you want to model. And you can actually get dimensions off of that. You can get information off of that and really build your digital library. And you can also, all of the footage that is captured by the Skydio drones are uploaded to the Skydio cloud. And this is something that you have access to, and you can integrate to the other platforms that you use within your workflow to manage the data and get the data where it needs to go. So I think one of the big issues when starting a drone program is really understanding how to manage the data, where to put it. The last thing you want is to have a pile of SD cards that sits in somebody's desk drawer or sits on a folder of somebody's computer that you just can't find when you need the data. So that is something that our software team has thought of, and our customer success team is here to help with those integrations and making sure that you get the data to everybody who needs to be able to see it. Let's see. Next question. Is there any on-the-edge AI incorporated into the drones besides obstacle avoidance? So I think for us, we have some of these platforms that I mentioned before. I think we are also understanding the need for an end-to-end digital solution, where I think many of the customers And many of the utility professionals that I've spoken to have expressed an interest of having an analytic after the data is captured in order to take a first pass and understand what exists out there. So I think there are other vendors that are exploring the space at this moment. That is not something that we have built out in-house, but that is something that we are exploring in terms of the need. And there are several vendors in different industry spaces that have platforms that do that. Let me look through here. Can the drone recognize differences from previous scans and missions and report an abnormality? So yes and no. And I'm going to put a caveat that I think our solutions engineers can probably answer this better. We do have the ability to do a time lapse. So you can take photos and put them against each other in order to see gradients or to see changes. So I think if you think about construction, for example, if you want to monitor the progress of a construction project, you can actually do that. If you want to monitor a specific location where you see or you anticipate a fault or you see cracking and you want to monitor the propagation, you can do that over time. So as I said, that's not something that is necessarily done with AI at the moment, but could be in the future. And it's something that you can use the data as it's collected and call it together and draw the conclusions. I think these are most of the questions that have come in. We are almost at time. So if there are any other questions, I could take them now. Alternatively, really appreciate everybody joining us today. If you have any other questions that come to mind or at a later time, please feel free to email them in at utilities@skydio.com. And please be on the lookout. As a reminder, please sign up for Smart Grid Series 2. This is going to be on August 1st at 1 p.m. Eastern, 10 a.m. Pacific. And we'll be discussing how utilities executives can build resilience by modernizing workflows that digitize and retain critical knowledge. So one of the concerns is to really reduce the impact of losing subject matter expertise amongst utility personnel. So you can find a link to that in the chat, and you'll also be receiving an email invite. So thanks again for joining. And